Look around you right now, feel the solid texture of your desk, and listen to the faint hum of the room. Everything about your physical world feels indisputably real, concrete, and grounded in absolute material reality. What if the most brilliant computer scientists and quantum physicists on Earth are right when they suggest that everything you experience is an illusion? What if our entire physical cosmos is not a standalone environment, but a high-level recursive cloud computing instance running on a higher dimensional server network? In the next 20 minutes, we are going to break down the exact mathematical and physical proofs that show our universe functions like distributed, cloud-hosted software. To understand how our reality operates like cloud infrastructure, we must first look at a fundamental problem in physics: how information is processed and stored. In classical mechanics, space was treated as a continuous, infinite background. But quantum mechanics proved that physical reality is digitized into discrete units. The Planck length represents the absolute smallest unit of distance, measuring roughly 10 to the minus 35 meters. Below this scale, the concept of physical position completely breaks down. Similarly, Planck time represents the smallest indivisible tick of the clock. This means space and time are pixelated, operating with a fixed spatial resolution and a maximum frame rate of 10 to the 43 frames per second. But a digital grid requires a processing engine to update the state of each pixel, bringing us to the core mechanism of cloud architecture: resource optimization. In modern cloud computing, servers use dynamic rendering and edge processing to handle massive amounts of data efficiently. A server never renders an entire open-world environment all at once. Instead, it uses lazy loading, rendering assets only when a client sends a request. Look at how our universe behaves at the subatomic scale. In the double-slit experiment, subatomic particles like electrons remain in a state of superposition, a wave function of pure mathematical odds, until a measurement occurs. The moment a detector or conscious observer interacts with the particle, the wave function instantly collapses into a definitive physical coordinate. Physical matter remains unrendered in a cloud state of probabilities until an active query forces the system to compute a local result. This brings us to the ultimate speed limit of our universe: the speed of light. Light travels at roughly 300,000 kilometers per second in a vacuum, and nothing in the cosmos can exceed this speed. In cloud networking, latency is the physical time it takes for a data packet to travel from a central data center to a local terminal. The speed of light is not an arbitrary law of nature. It is the maximum network throughput and clock speed of the underlying physical hardware rendering our reality. This bandwidth limit is demonstrated through Einstein's special relativity and time dilation. As an object moves faster through space, its progression through time slows down relative to a stationary observer. In cloud computing, when a system allocates processing power toward heavy client-side computations, local execution speeds decrease to prevent system overloads. Space and time share a single processing budget because they are hosted on the same infrastructure. To understand how this system achieves infinite scale, we have to look at recursive processing. Recursion occurs when a program calls itself within its own code to solve complex subproblems. If an advanced civilization inside a cloud-hosted universe builds a supercomputer, that computer can host its own virtual environment containing simulated entities. Those simulated entities can eventually build their own virtual computers, creating an infinite, nested chain of sub-instances running inside virtualized containers. This containerized architecture explains one of the most baffling phenomena in quantum physics: quantum entanglement. When two particles become entangled, altering the spin of one particle on Earth instantly alters the spin of its partner light years away. Einstein called this spooky action at a distance because it seemed to violate the speed of light. However, in a cloud architecture, two virtual objects that appear far apart on the client interface can reference the exact same memory address on the host database. When the state of a primary data node changes, every instance referencing that pointer updates instantly, bypassing the physical rendering engine's spatial distance rules entirely. Further mathematical evidence for this system was uncovered by theoretical physicist Dr. James Gates while analyzing supersymmetry and string theory. Inside the equations governing subatomic particles, Dr. Gates discovered linear binary block codes, error-correcting algorithms invented by Richard Hamming. Why would the fundamental laws of nature contain built-in data transmission algorithms? In cloud computing, error-correcting codes constantly run in the background to detect and repair corrupted bits across distributed server nodes. Finding error correction protocols within the equations of quantum gravity indicates that our reality actively maintains data integrity across a network, preventing the fabric of spacetime from accumulating structural glitches. When a system error does occur at an extreme boundary, the network executes a safety protocol. Consider what happens when matter collapses down into an infinitely dense singularity inside a black hole. In classical general relativity, a singularity represents a point where equations divide by zero, resulting in an infinite value that breaks down physical laws. In computer programming, an unhandled divide by zero error causes system crashes. A black hole functions as an isolated sandbox environment. The event horizon acts as a computational firewall, containing the unhandled exception behind a one-way data boundary so that local mathematical errors cannot corrupt the broader network state. This leads us to the holographic principle, which states that all the information contained within a volume of space can be fully encoded on its lower dimensional boundary. Just as cloud data is stored on distant server racks and streamed to your local display screen, the 3D reality we inhabit is a local projection streaming from data encoded on a distant 2D cosmic horizon. Your brain acts as an edge computing terminal, processing raw mathematical inputs into a user-friendly sensory interface. The desk, the sky, and your physical hands are desktop icons designed to hide the complex background code executing beneath the surface. If physical space is an illusion and reality is a recursive cloud-hosted instance, your existence remains deeply meaningful. The experiences, connections, and choices you make represent real data processing across the cosmic network. You are not an isolated spectator lost in a cold void. You are an active node within a vast, self-calculating system exploring its own infinite potential. Does the concept of a recursive, cloud-based reality change how you view your place in the cosmos? Let me know your thoughts in the comments below. Hit that subscribe button to keep breaking reality with us, and I will see you in the next dimension.